Now that you guys are more familiar with what kinematic quantities are, we're going to go over a couple example problems to get a better feel for how we use them. The first example we have is that this car, which we'll draw as a square because I can't draw very well, travels 100 meters to the east, and then it travels 60 meters to the west. What is the distance that it traveled, and what's its displacement? So to figure out the distance that it traveled, it's pretty easy. We can just look at how much ground it covered. It went 100 meters this way, so we'll add 100. And then it went 60 meters this way, so we're going to add 60. So the distance traveled is 160 meters. But what if we want to know what the displacement is? The displacement doesn't tell us how much it's traveled, it just tells us how its position has changed. So we want to look at where it started and where it ended. If we can set this spot here to be 0, and we're going to call to the east positive, we can pretty easily calculate the displacement by adding up the distance traveled. So we went first 100 meters in the positive direction, so we're going to add 100, but now instead of adding 60 again, we actually went 60 meters in the negative direction, because this way is negative. So we're going to subtract 60, which leaves us with 40 meters. So our displacement is 40 meters, but in what direction? We can do this by looking at the sign of our final answer. Because it's positive, and we said that east is positive, we know that we went 40 meters east. So that's how you'd find the displacement. We're going to do another one here concerning velocity. We've got a runner going around a track, starts here and does a full loop of the track and ends up right back where they started. If it takes the runner 50 seconds to go around a 400-meter track, what is their average velocity and what is their average speed? So speed is based off of distance. How far did they travel? Well, they went 400 meters. And how long did it take them? 50 seconds. So we can do 400 divided by 50 and find that their average speed was 8 meters per second. Now, velocity is a little trickier because velocity, we want to know what was the displacement and how long did it take. If we're looking for displacement, we want to know the difference between where we started and where we ended. If we started right here and ended right here, then our displacement is actually just 0. So we had a displacement of 0 meters over 50 seconds, which is actually just 0 meters per second. So while our average speed was 8 meters per second, our average velocity was 0. We're going to do one more question here concerning acceleration. If a bike starts completely still, it's a pretty good bike, and it's accelerating 2 meters per second squared for 5 seconds, then what's its final velocity? So what this means is that at the very start, the velocity of the bike is 0. But each second that passes, the bike's going to be moving 2 meters per second faster. So we can use formulas, or we can just think about this a little bit. If we gain 2 meters per second of speed every second, and we've been doing it for 5 seconds, then it makes sense that we can just say 5 times 2 is 10 meters per second, which is our final velocity here. And now we're going to ask one last final question about this, and this is how we're going to introduce a couple of the formulas. we're going to ask ourselves, how far did the bike travel? If it was accelerating 2 meters per second for 5 seconds, how far did it travel? We can derive this formula using calculus, but for now, I'll just show you it, and we can derive it in the next video. So our distance traveled, or our displacement, is the initial velocity, call it VI, multiplied by the time, plus 1/2 the acceleration multiplied by the time squared. So now, if we know our initial velocity is 0, our acceleration is 2, and our time is 5, we can plug all these values into our equation to find out how far the bike traveled. So we got 0 times 5 plus 1/2 times 2 times 5 squared, which is going to give us our final answer of 25 meters traveled. So this is one of the equations we're going to use often when we're dealing with kinematics, and I'll show you a couple more of them in the next video, and later on we can derive them using calculus. That's all for today. We went over a couple example questions, and in the next video we're going to be focusing on doing a little bit more complicated problems.